Good evening, everyone. This is Parathosh Reddy, and this is OSDA1, and my topic is Man to Tetris project. So, the idea of this project is to make a software using Boolean logic system. The universal gates and is used to implement the software. At the end of the project, we will be able to run games such as Tetris. The first task is to create a hack computer, then to create a multiplexer using NAND gate. So basically, what is an hack computer? Hack computer is made up of several components like RAM, ROM, and CPU. CPU acts as a mediator between RAM and ROM. RAM and ROM doesn't directly interact with each other. They use CPU as a mediator while interacting. The ROM consists of a bootloader program and hack machine language, binary code, while RAM is the operating system used in the application. So this is how to install the NAND Tetris software. So basically, after you open the site nan2tetris.org to download this thing, you'll get two folders popped up on the screen, tools and projects. You open the tools, you search for the tools available, and then you get doing with your project. Boolean logic. Boolean logic is basically divided into three types. It's AND gate, OR gate, and NOT gate. AND gate is basically whatever the input you give, if it contains a zero, the output will be automatically zero. And the only exceptional case in AND gate is when both the inputs are one, the output becomes a single one. And coming to OR gate, basically it also has two inputs. And if there is a one in any of the input, the result will automatically become one. And coming to the NOT gate, it's basically the reverse of what you give as input. You give one, the result will be zero. And vice versa, you give zero, the result will be one. This is basic diagrams of how they look like. Boolean expression and function. A Boolean expression is a logical statement that is either true or false. A Boolean expression refers to a function having n numbers of variables such as 2n of possibilities. Okay. This is basically a Boolean expression which includes AND gate, NOT gate, and two ANDs and one NOT and one OR. So that's how you write the basic Boolean function lines. Boolean identities. Basically, there are four laws: commutative law, associative law, distributive law, and De Morgan's law. Commutative, associative, and distributive are basically the same as the maths laws we use in the mathematics. The De Morgan's law, they include like other gates such as not or and not hardware description language HDL. It's basically the diagram is a XOR gate with two NOTs, two ANDs, and one OR. So the input A, B will directly go through these gates, and finally we get the output. The below diagram is about interference and implementation. Basically, the code how this thing works. HDL simulation. HDL simulation is divided into three components: interactive simulation, script-based simulation, and with or without output and compare files. We'll discuss them in detail. Interactive simulation. So basically, you load the HDL file into simulator, enter the value for each input. The output will consist of two parts: the final product and the output of each step used. In script-based simulation, you basically have two, what do you say, columns. One is the main thing, and second thing is the testing thing. So you don't directly give the output to the users. You first test the what the code is capable of. You know its errors and things. You sort them out, and you implement the main code. Yeah, this is the script-based simulation example. Multi-bit buses. Buses of which bits which are together and can be manipulated together are called buses. Each bus can be manipulated to get a desired output. Buses can be divided into subparts and called as subbuses. Example, you can see A of 0 to 7 LSB and A of 8 to 15 LSB. Yeah, project one. This is the basic commands which we use in the hardware simulation. Elementary logic gates such as NOT, AND, OR, XOR, MUX, and DMUX. And in the 16-bit variants, NOT 16, AND 16, OR 16, and MUX 16. In the multi-way variants, it's OR 8-way, MUX 4-way 16, MUX 8-way 16, DMUX 4-way, and DMUX 8-way. We need to build this 15 frequencies used in logic gates using NAND function multiplexer. Basically, these diagrams are examples of how these things work. You give them two inputs and they do the logical part and give you the single output. So that's basically the diagram, the truth table, and the code. A two-way multiplexer enables selecting and outputting one out of two possible inputs. These are basically used in crystal designs and also communication networks. Then now we'll see how do we simulate these things. So first you open your simulator, you open your XOR file, load chip. So now the code is ready. So we need to give the values. So first A and B are given values as 0 and 0. We'll change the A value as 1 and we'll run this. As you can see here, the output when we change the A as 1 becomes 1. Now we'll try to change the second one. So now both inputs are 1 and 1. So we run this. We get the output as 0, and that's how this works. Yeah, thank you.